Hello everyone. Today we are going to discuss basics of logarithm and their properties. Already in the last session we discussed about the definition of logarithmic function and clearly it is inverse of exponential. Let us discuss what is exponential and what is logarithm, and after that we go for basics of logarithm. First I am going to explain what is exponential. Exponential means rapid function it is. So maybe it increases rapidly or decreases rapidly depending upon the value of base a. Exponential function is defined by f of x equal to a power x, and it is defined for all real values of x. You know this definition, and the conditions to the base must be more than 0 and base value always not equal to 1. These are the conditions to the exponential function. And you know that suppose base value, if it is equal to 1, then what happens? In case base value 1, then for all x belongs to R, whatever the real value you write here, then it gives the result 1. Nothing but, observe the graph. If you put x value 0, 1 power 0, 1. If you put x value 1, 1 power 1, again 1. If you put x value 2, 1 power 2, again 1. If you put minus 1, also 1. So the graph consistently getting output 1, so that it is not rapid. There is no rapid growth or rapidly decreasing, so that it is not an exponential when you select base a equal to 1. So due to that reason you have to select a not equal to 1. And also given here a is only the positive real value. Why not it is negative? Let us observe first. If it is negative quantity, minus 1 power x, if I choose, what happens? Observe, when you put x value 0, it is plus 1. When you put 1, it is minus 1. When you put x value 2, it is again plus 1. So sometimes 1, sometimes minus 1, sometimes 1. So increasing, decreasing, increasing, decreasing, like that. So it is also not rapid. So due to these two reasons, a must be positive and not equal to 1. And depending upon the base, there are two graphs. Suppose base value in between 0 to 1, there exists one graph, and base value suppose more than 1, there exists another graph to this function. Suppose for example base value, if I choose 1 by 2, then what happens? Observe, in case base value is 2, then see the graph. We know that it is defined for all real values of x. First, if I give input 0, 1 by 2 whole power 0 gives 1. If you put 1, 1 by 2 whole power 1, that is 1 by 2 decreases. If you put x equal to minus 1, 1 by 2 power minus 1, nothing but 2. Here, joining all these points, the graph exists in this way. It is rapidly decreasing. So due to that reason, it is known as exponential function. Next, 2 power x. When base value more than 1, the graph increases. Let us observe, put x equal to 0, 2 power 0 become 1. If you put the value of x equal to 1, 2 power 1, nothing but 2. Next, if you write x value 2, it goes to 8. 2 power 2, that become 4. Next, if you put minus 1, 1 by 2, joining all these points, this is the graph. It rapidly increases. So this is about exponential function. And you know that logarithmic function, it is inverse of exponential. Logarithmic function is defined by f of x equal to log x to the base a. Base conditions are same. Again, a more than 0 and a not equal to 1. And here it is defined only for positive values of x. What I am saying, it is logarithmic which is inverse of exponential. Exponential function a power x, and it is defined from set of all real values, and it is getting output open 0 to infinity. Input is set of all real values, domain R, but output entirely positive. The graph is entirely above x-axis, so that output 0 to infinity. And for logarithmic function, since it is inverse of this, inverse, so that domain should be 0 to infinite and output should be set of all real values. And you know that inverse function, the graphs of inverse function symmetric about y-axis, y equal to x. Y-axis symmetry, it is symmetry about the line y equal to x. Why? Because y changes to x, x changes to y. And now this is the graph of y equal to x. This is the graph of y equal to x. And now I am going to draw the graph of logarithm. This one is the graph of log x. White colored exponential, green colored logarithm. And clearly the graph is symmetric about yellow colored line, that is y equal to x here. Next, this is 2 power x, right? Its inverse log x base 2, that is the graph exists in this way. Why? Because just now we discussed logarithmic which is inverse of exponential, and observe domain only set of positive real values but output any real number. Yes, the graph exists only right part of x-axis and defined only for positive values, as well as its output set of all real values. Minus infinite to infinite the graph exists here. Output values from minus infinite to plus infinite. This is about logarithmic function and already discussed in the basic concepts. Now let us move properties of logarithm. First property, log a power m to the base b, that can be written as m into log a base b. Remember, input a always more than 0 and base value more than 0 but not equal to 1. These are the conditions for existency of logarithm. Yes, let us see the proof of this. Assume that this is some p and this one as q. When you select log a power m base b as p and log a base b as q, so it is enough to prove that p equal to m into q. It is enough to prove that here p equal to mq. Okay, when you choose log a power m to the base b equal to p and log a to the base b which is equal to q. Okay, let us see. When you select log a power m base b equal to p, you know that b power p written as a power m and b power q that can be written as a. By selecting log a power m base b as p, log a base b as q, you got b power p value a power m, b power q value a. And from these two I can write, suppose if I substitute the value of a here in this, b power p become base value a that can be written as b power q, and then you have here exponent m. So b power p gives the result b power m into q. Due to same base, exponents are equal, therefore you will get p equal to mq. P equal to mq is nothing but log a power m to the base b equal to m of log a base b. So this is the first property. Remember, suppose 2 power 3 which is equal to 8. Here it is input and here output it is. Input to the exponential and here base value 2. It is like y equal to a power x. Y equal to a power x model it is. X input, y output. Since logarithmic function which is inverse of exponential, inverse of this can be written as log 8 to the base 2, that is 3. So whatever the output you have in the exponential, that here in the logarithm it is input, and whatever the value we use as input, that is output in the logarithmic. So this is y equal to log x base a model. So input output the interchange. So here 2 power 3 become 8, that you have here 2 power 3 equal to 8. When log 8 base 2 equal to 3, 2 power 3 written as 8. So here log a power m base b, if you assume p, b power p become a power m. Log a base b equal to q, b power q become a. So this is the proof of first property, and let us go to the next one. Second property, log a power m base b power n, that is m by n log a base b. Important result. See the proof of this. Suppose that if I select this part as some p and another part here in the right, that is q. If you select log a power m base b power n as p, log a base b as q, then it is enough to prove that p equal to m by n into q. Here it is enough to prove that left hand side p, right hand side multiple m by n and q. When you select this one as p and this one as q, see when it is p, when log a power m base b power n, if it is p, then you can write b power n whole power p, that become a power m. A power m here input to the logarithm, that become output to exponential with the same base b power n. Next, also log a base b, that is clearly q, that implies you can write b power q, that is equal to a. Yes. Now I am going to substitute b power q, you have a. I am going to substitute the value of a in this. What happens? Observe, b power np, this one, a power m, but the value of a b power q. So b power np equal to b power mq, a power m whole power n, that is a power mn. So here you will get, due to same base, np equal to mq, and hence p written as m by n into q. So you got p equal to m by n into q, nothing but this is log p value, log a power m to the base b power n, which is equal to m by n, and the value of q log a base b. This is the proof of second one. Let us see an example based on this. Suppose the question, if you have log 16 to the base 8, if you have this type of question, you can apply this property. 16 can be written as 2 power 4 and 8 can be written as 2 power 3. Now applying log a power m base b power n property, you will get 4 by 3 log 2 base 2, 4 by 3 constant outside, and log 2 base 2 value, that is 1. Why? Because if you raise 2 to the power 1, you will get 2. So it is 2 power 1 is 2, so that log 2 base 2 value become 1, and hence the answer 4 by 3. So this is second property. Let us move to third one. Property number 3. Log a to the base a equal to 1, and property number 4, log 1 to the base a equal to 0. See the graph of logarithmic function. In case there are two graphs, this is the graph when base value more than 0. Suppose base value more than 0, this is the graph. Log a to the base a, value 1 given in the property. Yes, when you raise the base a to the power 1, then only you will get the result a. So due to that reason, log a base a value equal to 1. A power 1 equal to a. This is input and this is output. Output now here in the logarithm input, and the output in the input in the exponential, that as output in the logarithm. So log a base a equal to 1. This is the property. Next, and the conditions apply: a more than 0, a not equal to 1, a not 1, a more than 0. Basic conditions, they are necessary. Next, log 1 to the base a 0. Yes, see the graph. When you go input 1, output is 0. Graphically it is very clear. It is passing through the point 1 comma 0, and hence when you give input 1, output is 0. This is property number 4. Next, let us move to another property. Property number 5. Log m to the base a plus log n to the base b, base a itself, that is log mn to the base a. Log m plus log n written as log of mn, and they are having common base a. Let us see the proof. Assume that this is some p and this one is q, and suppose this as r. So it is enough to prove that p plus q equal to r. And here when you select log m base a, when you select log m base a as p, and left side another term log n base a as q, and in the right part log mn to the base a, suppose if it is equal to r. You know that a power p written as m, and from this a power q written as n, and a power r written as mn. Now a power r, since it is mn, a power r written as m is nothing but a power p, and n is nothing but a power q, and a power r is clearly a power p plus q. Due to same base, r become p plus q. P plus q equal to r, nothing but log m to the base a plus log n to the base a equal to log mn to the base a. This is the result. And when you have sum in between log m log n, you got log of m into n. For sum you will get product, and if you have difference in between them, you will get division here, log m by n. Let us see the proof of next one. Next, property number 6. Property number 6, log m to the base a minus log n to the base a, that become log m by n to the base a. See the proof of this. Assume that this is some p, and this one as q, and this one as r. If you select log a power m equal to log m base a, log m base a if it is equal to p, and log n to the base a equal to q, log m by n to the base a equal to r, you can write a power p as m, a power q as n, and a power r as m by n. And it is enough to prove that here p minus q, that is r. When you select this one as p, and second one as q, and third one as r, it is enough to prove that p minus q equal to r. Now let us observe a power r. You have m divided by n. A power r equal to m is nothing but a power p, n is nothing but a power q, and in the right part a power m by a power n model it is, so I can write a power p minus q. Due to same base, r written as p minus q, or p minus q equal to r. P is nothing but log m to the base a, n is nothing but log n to the base a, and r value you have, that is m by n to the base a. So this is the proof. Next we go for another proof. Property number 7. log a base b, that can be written as 1 by log b base a, also that is equal to log a base c by log b to the base c. Let us see the proof of first one and then we go for second one. Suppose if you select this one as p and denominator part as q, it is enough to prove that p equal to 1 by q. Let us see the first one. Log a base b, p implies you can write b power p, that is equal to a. Next here, log b base a q implies a power q, that is b here. Substitute the value of b in this. B power p, you have a, b is nothing but a power q whole power p, that is equal to a, implies a power pq equal to a power 1, and hence you will get pq equal to 1, implies you can write the value of p equal to 1 by q, p equal to 1 by q. Yes, this is the property. Next proof, log a to the base b written as log a to the base c divided by log b to the base c. Assume that first one p, numerator q, denominator suppose r. So it is enough to prove that p equal to q by r. Now log a base b equal to p is nothing but clearly b power p equal to a, that is first one. Next, from this c power q written as a and also c power r, that become b. Now replace the values of a and b in this. B is nothing but c power r, for which you have power p. On the right side you have a, that is c power q, implies we get c power rp equal to c power q. Neglecting base c on both the sides, you will get rp equal to q, rp equal to q, or p equal to q by r also you can write. So you got p equal to q by r result, and hence log a base b equal to log a base c by log b base c. So these are the properties of logarithm. At a glance, all the properties I am going to write. Log a power m to the base b equal to m of log a base b. Next, log a power m base b power n, this is equal to m by n log a to the base b. Next, third property, log a to the base a equal to 1 log 1 to the base a, which is equal to 0. Next, log m to the base a plus log n to the base a equal to log mn to the base a. Next, log m base a minus log n base a equal to log m by n to the base a. Also, log a to the base b equal to 1 by log b base a, and you can write log a base b as log a base c divided by log b base c. These are the properties of logarithm, and they are very useful in problem solving. So the students, those who are aspirants of JEE, they must remember all the properties of logarithms carefully. Thank you so much. In the next session, we will discuss the problems based on logarithmic and which they are asked in previous entrance examinations. Thank you so much.